Good morning, everyone. So today we're going to focus on the regulation of blood sugar. And I just want to go back to sort of where we ended last class so that you can just sort of pick back up where we started. So at the end of last class, we were talking about negative feedback loops. In a negative feedback loop, there's a particular body condition that you want to keep at a specific level. If that body condition goes too high, what happens is there's a gland that will release a hormone, and the hormone will cause changes, that will restore the body condition back to normal. Similarly, if that body condition goes too low, usually there's another gland that will release another hormone, and that hormone will cause changes in the body that will return the condition back to normal if it goes too low. We're going to look at this as it goes with sugar regulation. These models, where you have sort of hormones that bring the condition back down if it goes too high, and then bring it back up if it goes too low, are called negative feedback. So in blood sugar regulation, let's say you've just eaten a large amount of sugar or a candy bar or whatever, your blood sugar increases, or there's more sugar in your blood. What happens then is that the pancreas senses that and releases the hormone insulin. What insulin does is it triggers three things. It triggers the body cells to take up sugar, and then it can use that sugar to make energy. We're going to talk more about how insulin causes this change in a second. Insulin also causes the liver to take up sugar and store it as glycogen. And it also reduces appetite, or makes you not be hungry after you've eaten a large amount of sugar. These three changes, particularly these two, cause the blood sugar level to return back to normal, because we're taking sugar into the body cells, and we're taking sugar into the liver. Now, similarly, if your blood sugar level drops after not eating for a while, there are ways that we can return it back up. And that's, in this case, when your blood sugar goes too low, the pancreas is still the pancreas. This is a hormone known as, and what glucagon does, is it triggers the sugar that we just stored in our liver as glycogen. It triggers the liver to release that into the blood. It also triggers you to feel hungry so that you'll start eating and probably take in more sugar. And the releasing of the glycogen as glucose into the blood and making you possibly hungry so you can eat will raise the blood sugar back to normal. Now we're going to take a look at how specifically insulin functions and to sort of bring about these events here that restore the blood sugar back to normal. So this should look very similar. It looks like one of those all over signal transduction pathways that we know and love. So what happens is when insulin is released by the pancreas, when your blood sugar is high, insulin binds to body cells or liver cells to a receptor in the membrane. Obviously, we know that when insulin binds to a receptor, it activates. This receptor is a tyrosine kinase receptor, so it phosphorylates this complex, this PI3 kinase complex. Which activates this. And what this causes is it causes this vesicle, which contains glucose transporters, to be inserted into the membrane. And then these glucose transporters can let glucose into the body cells. Before, when there was no insulin, these glucose transport proteins were not here, so glucose could not get into the cells. It had to stay in the blood over here. But when the signal transduction pathway activates these GLUT4 vesicles, they can be inserted in the membrane and they let glucose into the cell. Remember, glucose can't enter through the membrane because it's a charged molecule, and it's repelled by the fatty acid tails. So in order to let glucose into the cells, you have to have insulin to bind to activate a signal transduction pathway. And this signal transduction pathway will signal the GLUT4 vesicles to insert into the membrane, and then these transport proteins, which are called GLUT4, will let glucose in. Without the GLUT4 transport protein being in there, glucose won't be able to get into the body cells, nor will it be able to get into the liver. When glucose is let into the body cells, the blood has less sugar in it, and the sugar level returns back to normal. Remember, this is not happening in just one cell. This insulin molecule is binding to lots of cells and causing them to take in glucose. And then the level of glucose in the blood goes down because all the glucose is being transported into the cells of the body. This slide is a summary of blood sugar regulation. We'll go through it, and then we're going to talk about diabetes, which is when this process goes haywire. So once again, let's say there's an increase in blood sugar because of eating or taking in sugar. That causes the release of insulin. Insulin will then bind to the membranes of cells, and it will insert that glucose transport protein, which is called GLUT4, here glucose permease, and that will allow the cells to take in glucose. As a result, glucose will be removed from the blood, and then the level of glucose in the blood will go down or back to normal. Now, we're not going to go through this as much detail, but let's say your blood sugar goes down after not eating for a while. The pancreas, instead of releasing insulin, will release another hormone called glucagon. Glucagon will then bind to receptors, its own receptors, on the membranes of cells, and it works through a signal transduction pathway with the G protein and cyclic AMP, if you remember that signal transduction pathway. What this eventually causes, is the activation of cyclic AMP, and what cyclic AMP causes is the activation of an enzyme known as glucagon phosphorylase, and with glycogen phosphorylase, and what glucagon phosphorylase causes is it causes the liver, which stores glycogen, to break down glucose and release it into the blood. Let me say that again because I forgot how to speak English for a few minutes. So when glucagon binds to the membrane of liver cells, what it causes through a signal transduction pathway is the activation of glycogen phosphorylase. And what glycogen phosphorylase can do is that it breaks down glycogen into glucose, and then that glucose will release into the blood, and then the blood sugar will go back up. But again, this is all working through a signal transduction pathway. So the last thing we have to talk about is diabetes, but before we do that, let's just sort of review this process one more time. So when glucose is high in the blood, the pancreas releases a hormone known as insulin. And what insulin causes is it causes two main things. It causes the body cells to take up glucose, and then it causes the liver to store glucose in the form of glycogen. And that reduces the level of sugar in the blood. Conversely, if the blood sugar goes too low, the pancreas releases a hormone known as glucagon. And what glucagon causes, it activates an enzyme that breaks down glycogen and releases it into the blood as glucose. And then the blood level goes back up. So again, and this type of cycle, where there are sort of two ways, one way to bring it back down and one way to bring it back up, is called a negative feedback loop. Okay, now, normally I would write this on the board, but I'm going to have to speak slowly. You may have to pause and replay the video because this is where I would write on the board, but I don't have a board at home. And it's really hard to write on the computer. So diabetes is when this pathway of controlling blood sugar, releasing insulin, doesn't work correctly. There are two types of diabetes. The first one is type 1 diabetes, and usually you're born with type 1 diabetes. And type 1 diabetes is actually an autoimmune disease. What happens is the body attacks the pancreas, and it no longer makes insulin when the blood sugar goes back up. So nothing triggers sugar to be taken into the body cells. So people who have type 1 diabetes will never make insulin, and as a result, the sugar will never go into their blood, their cells, and they won't be able to make energy. And their blood sugar will stay high. Type 1 diabetics, after they eat meals, inject themselves with insulin. And the insulin will then trigger their cells to take in blood sugar, but their body does not make it naturally, so they have to inject themselves with insulin after they eat meals. Nowadays, some people actually have auto pumps that are attached to their body, so they don't have to sort of carry around insulin. They're attached to their body, and they auto-inject the insulin when you set them for a certain time. But type 1 diabetics do not make insulin. They have to inject themselves with insulin after they eat meals, so that will trigger their body cells to take in sugar. Otherwise, they would not take in sugar, and the blood sugar would remain high. And then their body cells would never be able to make energy. In type 2 diabetes you develop later in life. They don't exactly know what causes it. Some risk factors are being overweight. It also tends to be more common in certain groups of people or certain ethnicities. But in type 2 diabetes, the pancreas can make insulin, but for some reason, the cells don't respond to it. So this I'm going to try to draw. Pointer options, pen. So in this case, you'll have a cell in type 2 diabetes, and there'll be, for some reason, the receptor, there's my receptor protein, doesn't respond to insulin. So insulin is made, but for some reason, something's wrong with the signal transduction pathway where the cells cannot respond to it. And then, so that won't trigger the signal transduction pathway, and the end result will be that there won't be that glucose transport protein put in the membrane, and then glucose can't get into cells, and the blood sugar will remain high. Usually, injecting yourself with insulin if you're a type 2 diabetic doesn't work because you're making insulin. It's just that the cells can't respond to it. Usually, people who have type 2 diabetes, they adjust their diet. They eat smaller meals and sort of reduce, they never sort of intake large amounts of sugar. Usually it's an adjustment of diet, and sometimes the situation actually fixes itself after they adjust their diet. But scientists or doctors still don't know why or what causes sort of this pathway or the receptor or the signal transduction pathway to stop working. They don't have an idea about why that's the case. It just does, and they know that some risk factors, eating lots of sugar and being overweight, cause that to happen. But they don't know the direct reason why, for some reason, the receptors or the signal transduction pathway stop working, or lose their sensitivity to insulin. Okay, so your homework, if you remember, is to answer the guided questions. It looks like it's probably not going to snow on Sunday that much, so I will see you guys on Monday. So answer the guided questions for homework.